This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 9 of graphing trig functions. We're going to continue graphing the sine function, and we're going to do y equals -2 sine of x plus 5 pi over 6. Now, because inside we have x plus 5 pi over 6, we have a phase shift, that's a horizontal shift, but we also have this -2 out in front. So there's a couple things going on here. This is going to, stretch the graph, right? So it's going to be taller. It's going to stretch the graph because this is going to give us an amplitude of 2. But notice it's flipped. The negative sign means it goes down first. So I'm just going to draw it like this. When normally the sine function goes up, right? Goes up, then back down, and repeats. But this one's going to go down first. And so people call that, you could say that flipping through it, or it's a mirror image, however you want to think of it. Now, what about this x pi over 6? So remember what we do, we take what's in the parentheses and we set it equal to 0, and that's going to tell us our phase shift. So the negative sign tells us it's going to go to the left, so it's 5 pi over 6, actually to the left will be our phase shift. And I'm going to move this over here so I have room to write. Okay, so the phase shift is 5 pi over 6 units to the left. All right, so now let's work through the problem. All right, so we're getting ready. So we're going to graph y equals -2 sine of x plus 5 pi over 6. I already solved for what's in this parentheses, setting it equal to 0, and that's how I got 5 pi over 6 units to the left. The period is 2 pi because that's the sine function. The period is 2 pi. The domain is -infinity to infinity. X could be anything. And the range, because the amplitude is simply 2, is between -2 and 2. All right, so now how are we going to get our 5 key points? All right, to get the 5 key points here. And by that I mean, of course, the ordered pair. What am I going to do to the x values here? I'm going to subtract 5 pi over 6 from the x coordinates of these key points. All right. But what about the y coordinate? What's going to happen? This -2 tells me if I know the sign of x plus 5 pi over 6, I'm just going to multiply everything by -2. So I'm going to subtract 5 pi over 6 from the x coordinates, and I'm going to multiply the y coordinates by -2. Now be careful here. It's easy to get this backwards. When it says plus 5 pi over 6, remember you set it equal to 0, and that's why it ends up being -5 pi over 6. So make sure you're subtracting. You're not adding 5 pi over 6. You want to figure out how you're going to get a 0 in that parentheses, and that would be -5 pi over 6. Okay. So here we've got our, so let's see, I'm going to have to go down a little bit. So we're looking at these ordered pairs right up here for x and sine x, and how am I going to get my coordinates for x and y. So first let's just work on the x. Okay, what am I going to do? I'm going to subtract 5 pi over 6. Okay, so 0 minus 5 pi over 6. I'm just writing what I'm doing down, and I'm going to put it here. You do not need to write it in two places, just so you see what I'm doing. I'm taking that 0 and subtracting 5 pi over 6. So that's one of my x-coordinates. Then I take my second x-coordinate, pi over 2, and I also subtract 5 pi over 6. Now here's where we have to get a common denominator. So this will be 3 over 3. So that gives me 3 pi minus 5 pi, which is negative 2 pi over 6. Now you can keep doing this, or you could say, oh, how did I get from negative 5 pi over 6 to negative 2 pi over 6? What happened in the numerator? I added 3 pi. So my next x-coordinate should just be 3 pi more than that. All right, so if you add 3 pi to negative 2 pi, that gives you pi over 6. It's the easy way to do it. If you add 3 pi to that, you'll get 4 pi over 6. And if you add 3 pi to that, you'll get 7 pi over 6. Now, if that's confusing for you, just go ahead and keep going with this next x-coordinate, which was pi, and subtract 5 pi over 6. Right? You just do that as well, and then you'd have to multiply 6 over 6. Notice that still gives you pi over 6. This fourth x-coordinate was 3 pi over 2 minus 5 pi over 6, and if you get a common denominator, again, that gives you 9 pi minus 5 pi. There's your 4 pi over 6. And the last one was 2 pi minus 5 pi over 6. Again, getting a common denominator for this, I'd have to multiply by 6 over 6, and 12 minus 5 is 7 pi over 6. In any case, these are our 5 key x-coordinates. All right? So two ways to get it. The first two, you just subtract the 5 pi over 6, and then you subtract 5 pi over 6 for the second one. And then you could do that for all 5 key points, or you can just, once you figure out, you just add 3 pi to get to the next one. That's the shortcut I like. Okay, now, what about the y-coordinates? Well, normally the y-coordinates go 0, 1, 0, negative 1, 0, right? That's usually how it goes, right? But I'm doing y equals negative 2, right? Times the sine of x. Was it plus pi over, I think it was plus 5 pi over 6. So what happens is, I don't just get to take the y-coordinates up here. Let's see, look at those y-coordinates. All right, 0, 1, 0, negative 1, 0. I got to multiply it by negative 2. So my y-coordinates, I got to pay attention to this part right here, multiplying each of my y-coordinates by negative 2. So that would give me negative 2 times 0, which is 0, right? Negative 2 times 1, which is negative 2. Negative 2 times 0, which is 0. Negative 2 times negative 1, which is 2. And negative 2 times 0, which is 0. All right, so I'm doing negative 2 times the usual sine of x values, 0, 1, 0, negative 1, 0. That gives me 5 ordered pairs. Negative 5 pi over 6, 0. Negative 2 pi over 6, negative 2, pi over 6, 0. 4 pi over 6, 2, and 7 pi over 6, 0. And I want to keep these with a common denominator so that I know how to label my x-axis. So my x-axis, they're in terms of 6. So I'm going to have to go 6 spaces before I do pi. All right, so again, here's our function. Y equals negative 2 sine of x plus 5 pi over 6. I'm just consolidating what we just did in the previous screen, where these are the ordered pairs we want. So I know on the x-axis, I need to do it at increments of 6. Now, this is the very important point. To make your graph look correct, you've got to be careful. Now I'm going in between negative 5 pi over 6 and 7 pi over 6. So I'm going about 5 to the left and 7 to the right. So I'm going to put my y-axis about right here. 1, 2, 3, 4, 5, 6. That's going to be negative pi. Okay. And then to the right, 1, 2, 3, 4, 5, 6 is positive pi. That's the same thing as 6 pi over 6. And then 7, 8, 9 pi over 6, etc. And we're going in between 2 and negative 2, so I'm just going to say there's 2. There's negative 2. Sorry, my y-axis looks a little ridiculous. Okay, so now let's graph these ordered pairs. We've got negative 5 pi over 6, 0, so we're going to count. 1, 2, 3, 4, 5. There's negative 5 pi over 6, 0. Next, we're going negative 2 pi over 6. Well, you could think of it as going 3 to the right. Remember, I was adding 3 pi over 6, or you could just start again here and go negative 2 to the left. But what's the y value? Negative 2, down here. Then we've got pi over 6, 0. So now we're at the positive side. 1 pi over 6 is right here. And we've got 4 pi over 6, 2. So we count 1, 2, 3, 4, up 2. And 7 pi over 6, so we got to count 6 pi, 7 pi over 6, 0. And hopefully you see how the shape is shaping up here. So we just sketch. Make sure you always round this. It's a nice smooth curve, the sine curve. And it starts, going down again, whatever. Just put a little arrow to show me that you know what's going on after that. And there we have it. Make sure that you're very consistent on your x-axis with these markings, and it should look like a nice smooth sine curve. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.